Hello again. Welcome back. About a week ago, somebody asked if I would create a Hello World program for Fuselage. Now, I don't consider the project far enough along that I think I could recommend somebody start making a game with it. Though, don't get me wrong, you definitely could. All of the components are there for you to do a lot of the graphic related stuff. So, with the stuff that is not there, you could fill the gaps with RayLib, which, since this project relies on RayLib, wouldn't be that hard to do. Now, I am going to decouple Fuselage from RayLib eventually. Right now, it's just basically a whole lot easier to uh, implement a lot of the things I want to do using RayLib because I'm moving to Vulkan, but that involves a whole lot of things that I haven't tackled yet: window management, input management, stuff like that. There is going to be a transition period where not a lot of actual work is getting done on Fuselage itself because the back end that I'm creating for this project is so far from complete that I'm relying on RayLib and other libraries to get things done. Eventually, the goal of Fuselage is to have as few dependencies as possible. So, when I reach that state, things will change dramatically. But for right now, you could, using RayLib and other libraries, create a complete game. Now, one might ask, why would you use Fuselage if you could just use RayLib and it provides all of the features you need to make a game already? And that's a great question, which is why I go back to the original statement I made about not sure that I would recommend building a game with Fuselage, but it does make some things easier. Now, one of the major advantages, I guess you could say, of Fuselage is that um, I have a couple of programs, a sprite converter and a tile converter, that lets you take bitmaps or images like PNGs and convert them to bitmaps and palettes, which pack them down and embed them in your program automatically. Now, as you can see here, I've included the headers I need to work with the sprite layer, and the text layer is just there for some feedback. Um, and I've included the asset files for some text called collision and the player sprite. Now, I'm going to use the same sprite for the player and the NPC, and this isn't really a game; it's just a demonstration. But it will make the point, get the point across just fine. Now, I also include the text layer because it does give us a little bit of feedback on some things, but I'm going to use the sprites to show the collision text. Now, text layer could be used by the developer to print out information such as score and game state stuff, but I don't recommend doing that. If you remember the old school games on things like the NES and Super NES and Sega Genesis, TurboGrafx, all of their text were in text on the tile layers, and that's exactly how I would recommend a developer using Fuselage do their text. You could use Pixies. That's a completely different subject, though. We will get into that later on. In this video, we're going to simply cover the sprites, but I just want to show that for some types of text, sprites are going to be good enough. Now, I've used my sprite converter to take the word collision and divide it into two sprites, the left and right side of the word, because the word is too long to readably pack down into 64 by 64 pixels. So I've created two sprites, set them side by side, and our collision text will be rendered using a couple of sprites. I've got some definitions here for some of the text output that we're going to be doing. I set the target frame rate, and I've created two little functions here that they're not really anything I would use in a commercial game or anything, but for these demonstration purposes, they work well enough. Handle input, of course, just queries the keyboard and joystick every frame, and the get gamepad left stick rotation lets us know what direction the player is moving in. Now, I also set a few states here: the exit flag, the frame rate, which defaults to 0, and of course it'll get updated every frame. The scroll for the X and Y, and the speed, which we could adjust that if we wanted to, but it's just there for like I said, this is just a demonstration, so none of this stuff is really that important. I do set some locations for the player and the NPC. The player position won't change every frame, only the NPC position. We're going to change the player's rotation and update the NPC ship every frame to give the illusion of the player moving around as they approach or fly away from the NPC ship. Of course, we're doing things on Windows with this demonstration, so if you're using Mac or Linux, this would be different. Ultimately, Fuselage will not be developed using this kind of situation here. We're not going to be doing things using the main function in Windows or Mac OS or Linux. I'm going to have a separate execution. I don't know what you'd call it. Ultimately, Fuselage is going to be a VM. So there's going to be this bytecode that all of the game will be running inside of. So the developer won't be dealing with most of this stuff. This will all be handled by the engine. But since we're doing everything in C right now using RayLib, I mean, there are some things we're going to have, and they're taken care of here. But this demo is not really about any of that. You can take a look at all of this code. It'll be available for free. We're going to concentrate on the sprite-related functions. Now, we, of course, have to start off by initiating the character maps so we get some text. We got to initiate the sprite layers and the palettes. We have to set them up. The first thing we do is load a palette for the player sprite. And we could use any number we wanted. There are 255 or 256, I guess, if you count 0, but 256 palettes to choose from. And it really doesn't matter which one we use, but once we set one, that's the one we're going to want to use for any sprite that uses it. So in this particular case, we load a palette into palette number 10, and then we set the color palette for sprite number 10 into palette number 10, and then we assign the sprite bitmap for the player ship into sprite 10. Now this only has to be done to initialize the sprite. The engine maintains all of this, and this will never be done unless it changes inside the program's main loop. We set the position, we set the visibility, and we set the enable. The enable will keep the sprite's state, the location, the palette that it's using, but the visibility determines whether or not it's going to be seen every time the frame is updated. Now, we do the same thing with the NPC sprite. The ship is set. We use the same palette that we're using for the player, and we set the visibility to true. But on this collision text, we're using two sprites, sprite 20 and 21. The numbers don't really matter. The developer will choose which sprites he wants to use. If you created some kind of entity management system, you might have it allocate dynamically which sprites are assigned to which. There are functions for determining what bitmaps are assigned to what sprites. And, smart developers will have an entity management system that will allocate sprites as they need them or deallocate them as they don't. Fuselage will basically retain anything you set. So if you assign, like in this case, the collision text to be 20 and 21, then that's going to be the state of that sprite until we change it. And of course, we assign the two sprites, 20 and 21, to Kali and Jun collision. And then we set them to enabled, but we set them visible to false. And this is because we don't want to see the collision text unless there is actually a collision. Of course, we set the position to be just underneath the NPC. And then we begin our while loop, which will run every frame until the program ends. We get the frame rate, set that into FPS, which our text layer will display every frame. And we set the visibility of the collision text to be false every frame because we don't want to see it unless there is a collision. We get our input from the joystick, and we store the direction of travel in JoyRot, scroll the screen based on that, and every frame we update the sprite position of the NPC ship. We check for collision, and there are several collision functions. We're using the rotated pixel collision because the player sprite will rotate depending on the direction it's traveling. And there are collision functions that are just bound boxes. There are collision detection routines that are pixel perfect, but they all do different things, and we want to check for collisions between sprite 10 and 11 based on the rotation of player sprite 10, because if we're just using bounding boxes, the player might collide with the NPC on pixels that don't actually overlap. So even though it doesn't look like the player's ship touches the NPC, if I wasn't going on a pixel by pixel perfect rotation calculated routine here, you might get a false positive on a collision because the bounding box is touched. But with this particular function, we can get a little bit more granular control on that collision detection, and in some cases, this is going to be desirable. Now, there are other functions which will return any collision. Any two sprites, it doesn't matter which ones, will automatically return a true, and that may be useful in certain situations. So there are a bunch of different collision functions, and if you decide to use Fuselage, I recommend you look inside the header file for the sprites, because the function names are pretty well self-descriptive, and you may find that in some cases sprite collision detection in this fashion is more applicable, but in others it would probably be overkill. Now, they're all pretty quick, so if you use this one most of the time, it would probably be fine if you're only comparing a few sprites. But if you have, like, say, 500 sprites on screen, and all of them were using a more advanced collision detection, well, I mean, depending on the person's system, that could incur a small penalty for performance. And that'll go away once everything's done in Vulkan, but right now, since we're doing everything in RayLib, that could really add up. The functions that I provide, though, you can look them over, and you may find that in certain situations, some of the more basic ones might be good enough. We update the position of the NPC's collision text if there is a collision, and we set the visibility to true. Now remember, the sprite for 20 and 21, which is the collision text, is going to remain there even if it's not visible. It's handled internally by the engine, but it's only changed its location if there is a collision, and then we only show it if it's true. So if we were to change the logic so that it would show it no matter what, it would probably only stay in the same place on the screen where it showed when the player collided with it. But since we're actually hiding it every frame, we only see it when there's a collision, and it will always be up to date based on the position, because that gets updated whenever there's a collision. This block of code right here does the basic stuff that RayLib does for beginning the drawing, clearing the background, displaying the sprite layer and the text layer, and then in drawing, and of course the loop repeats. When Fuselage is more mature, all of this is going to go away. The developer won't have to handle any of this. They're just going to handle their game logic. All of the states of all of the different components of Fuselage are handled by Fuselage, and all they do is change the states using their game logic. This frees the developer from having to worry about graphics at all. They simply import their assets, assign them as they need to, update the states, and the game basically is handled completely with their logic. All of the engine stuff is handled by Fuselage, which is how a game engine should be. Of course, we run this loop until the program exits, and then we do a clean shutdown, and that's basically this program. So I'm going to go ahead and give you a little demonstration of the program. Here are the two little functions I use for the handling the input and the direction of the joystick. They're not really important for this demonstration, but if you want to take a look at them, they'll be in the source code. We'll go ahead and run this and give a little demonstration of this program here. And as you can see, the player can control the ship, and using the sprite rotation function to draw the player sprite rotated based on the direction it's traveling. And of course, we can come real close. The bounding boxes are probably touching, but we're not getting a collision here until, oh, look, they're touching. We got a collision. And of course, every frame that sprite is disabled because there's no collision, and we can see the collision every time we touch. Pretty straightforward system. You could build a complete game just using this and all of the other functions of RayLib for handling sound and, you know, I/O and all that other stuff. You could pretty easily build a game using just what I've got right here. Now, this demonstration is just for sprites. You can see that there's some text here, but as I've mentioned earlier, you would want to display game-related text using either sprites or tiles. And this demonstration is only for sprites, so there will be a follow-up video explaining the tile layers, and you can expect that sometime soon. It's going to be a little bit more involved. I'll probably build on this application and make some parallax stars in the background or something. We'll figure it out when we get there. But for right now, I just wanted to show this off. I'll put the source code up available either on GitHub or maybe Patreon. Now, my Patreon is free. Most of the stuff I post is either time-locked to members or publicly available. I'm not really running Patreon as a way to make money. Just not really what I'm in it for. In fact, I probably don't even need the Patreon, but it is a place to post some going-ons as they happen, and if you want to keep track of things without having to look at my videos every time I make one, that's a good place to keep track of some of the stuff I'm working on. Stuff that's not really Fuselage related, but it is built with Fuselage. Some of the little demos and toys that I build with it, they're going to be up on Patreon. I think this source code is going to end up in an examples folder on GitHub, so you can find me at JaceFuse. I'm JaceFuse on GitHub, and the project is Fuselage. This program will probably get built upon, but for right now it makes a good little sprite demonstration, and feel free to check it out and play with it. If you want to use it, you're going to need to know how to use RayLib, and I'm not really sure that I should spend time explaining how to set up and use RayLib if you don't already know. There are good videos on YouTube for that. And if you're not familiar with RayLib, you're going to need it right now if you want to play with Fuselage. So I do recommend looking that up and getting familiar with it. After that, though, in time, when I make this completely dependent on itself and not any external dependencies, you won't need RayLib anymore to use Fuselage. In fact, I'm probably getting away from doing things directly in C. Once the back end is complete, there's going to be a virtual machine that is that's a good way away, so I really don't need to get into that right now. Just keep in mind that right now any of these components, if you want to use them, can be used on their own, and that will always be the case. Even after I get things pushed forward into the whole Fuselage VM RISC-V emulator kind of whole ecosystem thing, none of the tools will be compulsory. None of the components will be compulsory. You could pick and choose any piece of this to modify and use in your programs, learn from, or improve. If you see something and be like, man, this kind of sucks, but it's a pretty good idea, let me go ahead and fix this up and use it. I would appreciate the feedback. I would appreciate maybe any improvements be submitted, but there's no requirement for you to do so. This is just an experiment. It's developed as a passion for low-level, high-efficiency, very small code. So at some point, when I get the VM going, games will be developed using a kind of a custom RISC-V inspired scripting language, a pseudo-assembler thing. Details to come, because I still haven't worked it all out yet. But the idea is that I want games to be a very old-school type of development workflow. The idea being that you create a game and it plays on every target system exactly the same. Kind of like if you were to develop a game for the Super Nintendo and then run it on an emulator on Windows, Mac, and Linux. Fuselage is basically a development system where you write a game, and then once it's built with this system, it runs on all the target platforms exactly the same. So it's kind of like an emulator for a system that never existed. At least in theory, that's where it's going to be. Things could change between now and then, But at all stages of development, all components will be available for anyone to play with, experiment with, learn from, further develop if they want, or even use just in part in their larger projects which are not based on Fuselage. Honestly, I really am not developing this in a way that would require anyone to either even give credit. I mean, if you do use any parts of this, I would like to hear from you. I'd like to see what you're doing with it. But if you find some small piece useful in your code and you choose to use it and you don't feel it's significant enough to let anyone know where you got it, hey, that's on you. But I do look forward to anyone who finds this useful collaborating with me, contacting me, letting me know, maybe bounce ideas off of each other. If you have questions or comments, feel free to either leave them in the comment section below or contact me. And, hey, this video was inspired by a comment by another user, and I can't remember who it was, but thank you for the suggestion. And I hope you find this useful. And if you have more questions, feel free to reach out. That's all I've got for now. There will be follow-up videos. This is, I guess you could call this part 1 of the Hello Fuselage demonstration. And the next one will probably be about the tiles. And I would look forward to seeing, or I would expect to see that looking forward here in the next, I don't know, sometime in the future. You won't find it in the past. Don't bother looking there. But it's coming eventually. Maybe by the end of next month, maybe by the end of the next couple of weeks, I don't know. I'm spread pretty thin between a lot of different things right now. The whole back end on Vulkan thing is really taking a lot of time, because that's not just development, but also a lot of research. And to be completely honest about it, I don't exactly know what I'm doing, but hey, I didn't know what I was doing when I did any of this, so you just kind of figure things out as you go. That's all I've got for now. Take care. Do the whole YouTube thing, with the little buttons down below. Not really doing this necessarily for the recognition or the fame or the fortune, and it's certainly not going to make me rich, but, I do want to keep in contact with those who are like-minded and have a passion for development and classic games and retro game aesthetics and old school development methods. So yeah, if we can grow this channel and create a little network of other people who like to waste their time doing things the way no one else does them these days, then hit me up. In the meantime, play some games, drink some beer, eat some sausage, and try to stay alive.